Looking at the facts, discovered in 1981 by Kirshner, about 330 million light-years across, only 60 galaxies inside instead of thousands, and galaxies arranged in a tube-like pattern. Silence, not the hush of space. This is the void where space should be, a cavity 330 million light-years wide, stretching farther than the distance from our galaxy to the next major cluster. Astronomers expected a dense swarm of galaxies here. What they found was a profound, measurable absence, a region where the cosmic density plummets to near zero. The expectation was shattered by the data. Robert Kirshner and his team at Harvard were mapping galaxy motions using the CfA Redshift Survey. They painstakingly measured the redshift of light from over 2,000 galaxies near the constellation Bootes. Each spectrum revealed a galaxy's speed and distance. Processing the data over 18 months, the emptiness emerged not as noise, but as a stark, undeniable void. It was no error. It was a gap in the cosmic fabric. The numbers were staggering. Within that immense volume, only 60 galaxies existed. The expected count, based on surrounding regions, was over 1,500. This wasn't merely empty. It was exceptionally empty. The galaxies that did exist weren't scattered. They formed a narrow, elongated filament, a tube of light stretching 20 million light-years long within the void's center. Not random, but arranged with eerie precision. This tube pattern is the void's most persistent clue. It suggests the void formed along the natural seams of the cosmic web, where filaments converge. Voids are common, but this one's scale pushes the limits of current models. Astronomers still trace its faint outer edges with modern telescopes. The void doesn't speak. It only leaves evidence in the cold light of distant stars. The case remains open. The filament holds. 60 galaxies trace a single thread through the void's center, stretching 20 million light-years. Not a random scatter, but a precise alignment. This pattern mirrors the cosmic web's natural flow lines. Galaxies cluster where matter accumulates, along filaments connecting dense nodes. The void's emptiness isn't uniform. It follows the web's structure. The filament sits exactly where cosmic gravity should pull matter. It's the fingerprint of formation. Astronomers confirm voids form naturally as matter clumps into filaments and nodes. The cosmic web is a fractal structure of dense and empty regions. This void fits that pattern, just on a larger scale. Its size, million light-years across, pushes known boundaries. But simulations show such structures can emerge. The filament's location aligns perfectly with predicted cosmic seams. It's not defiance. It's the web's architecture revealed in stark relief. One theory proposes the Bootes void is a statistical anomaly. Our local region might be unusually sparse. Nearby clusters like Coma and Hercules form a dense wall. The void could be a gap between them, a natural extension of the web's void network. Astronomers estimate such underdense regions exist, but this one's size is extreme. Its filament might simply be the densest remnant clinging to the void's edge. A competing explanation suggests dark energy's role. If dark energy's influence was stronger locally, it might have inhibited galaxy formation within this vast region. However, current models don't require such localized dark energy effects to explain the void. The filament structure strongly supports the cosmic web formation theory. Dark energy remains a possible factor, but not the leading explanation. Modern telescopes map the void's faint outer edges. They trace the filament's end, searching for the next cluster or wall. The evidence is clear. A void formed where matter was naturally pulled away. The filament is the scar of that process. Yet the void's sheer scale challenges precise modeling. It remains a testament to the universe's uneven texture. The case is documented. The verdict awaits more data. The void holds its silence. The void stretches cold and dark, 33 million light-years across the map. Only 60 galaxies flicker within its emptiness. That's 1,000 times fewer than expected. Imagine a city block with no buildings, just empty streets. This is the Boots void. Its size defies easy explanation. The cosmic web theory offers the cleanest path. Matter clumped along filaments, leaving voids behind. But this void scale is extreme. Current simulations rarely produce such vast emptiness. It sits like an anomaly in the expected pattern. The filament's tube-like structure is clear evidence of matter being pulled away, yet models struggle to replicate its sheer size. The void's edges remain stubbornly silent on how it formed. Dark energy's role remains speculative. The idea that it locally slowed galaxy formation lacks support. Cosmological models don't need this tweak. The filament's structure is the key evidence against it. If dark energy were the cause, the void would show different features. It doesn't. The filament is the scar, not the wound. Dark energy is a possible suspect, but the evidence points elsewhere. Modern telescopes trace the void's faint edges. They follow the filament's ends towards the next galaxy cluster. This mapping reveals the void's true shape. It's not a perfect hole. It's a place where the cosmic web thinned. More data is needed. We need to find similar voids in deeper surveys. Only then can we confirm if this is a rare event or a common feature. The case remains open. The evidence is clear. Matter was pulled away, forming the void and the filament, but its size challenges our models. Why is it so large? No theory fully explains it yet. The universe holds its silence. It offers no more clues. It simply is. How much silence can the universe hold?